Hello and welcome to this tutorial. This is Casey and today we are looking at where do 16 million plus colors come from. I know maybe you've never asked yourself this question, or maybe you wondered how do we have 16 million colors while we only have 3 primary colors. Well, let's find out. Now, before I go into breaking it down to understand where 16 million colors come from, you all know or heard or been told that our computer only understands zeros and ones. How does a computer understand zeros and ones? Does it make sense to you, or is there a way to figure out how this works? Well, let's go back to the basics. When we started learning about numbers, we knew about counting from 0 to 9. And then after 9, we go to 10, 11, and it becomes double digit, triple digit, and so on and so on. However, in computer, it doesn't work this way, and I will explain why. But going back to the basics of our numbers, we understand that in this context, we have 10 placeholders, hence we call it base 10. How do we end up using base 10? Maybe it's because of we have 10 fingers, or maybe it was easy for people to do this for whatever reasons. That's besides the point in this video. First of all, how do we use the base 10? We know that we have ones, we have tens, we have hundreds, we have thousands, 10,000, 100,000, 1 million, and so on and so on. But what your lecturer or your teacher never told you is that these values are actually the powers of 10, which we have 10 to the power of 0, which is 1. For your information, any number raised to the power of 0 is actually 1. Then we go to 10 to the power of 1, 10 to the power of 2, 3, 4, 5, 6, and so on. So, how do we use base 10? Suppose that I tell you you have 200. You place 2 into the hundreds position, and if I told you we have 50, we place 5 into the tens position, and if we have 4, we place 4 into the ones position. Adding this together, we have 254. I know this concept looks kinda, why are you telling these things that we learn from our really basic numbers? But this is very important for you to understand the zeros and one into the computer. Let's go ahead and first again get the confusion of why this screen still displays zeros and ones. Please break it down. Now, zeros and ones are actually the only two numbers a computer knows. But what about the other numbers? First thing you need to understand is that 0 and 1s actually has 2 place values. And these 2 place values are actually make it base 2. Okay? Which is also known as a binary number. And binary number uses the same concept that we use in base 10, where we get the powers of 10. In base 2, we use the powers of 2. So we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, to the power of 4, 5, 6, and so on. That gives us 1, 2, 4, 8, 16, 32, 64. And by now you should be like, this is where we have 64 bits, 32 bit, or 16 bit. Yes, and again, the question comes in, how do we figure out 3? Where do we get 3? How do we get 5? How do we get 7? How do we get 9, 10? How are these numbers generated if this is the computer uses base 2? Let's go ahead and figure it out. I have 4 rows here. The first row represents 1. The ones in my rows represent the position of the powers of 2, which means at the 0001, it's actually 2 to the power of 0, which is 1, which is the first position. Second position is 2. Third position is 4. And fourth position is 8 from the right to left. Now, as I said, this is the representations of the powers of 2. The question still comes back to how do we get 3? If I was to put 3, what I'll do is I will combine 1 and 2. And 1 and 2 is 0001, 0010. If we add those two together, we get 0011, and that is a representation of 3 in binary. How about 5? Same thing applies. We pick 4 and 1. We pick 0001, 0100. That gives us 0101, and that is 5 in binary. So the bottom line is you can represent any number using these powers of 2 to pick up 1,000,000, 10 million, whichever value you can extract from zeros and ones. For ease of reference on binary numbers, what we usually do, we use a 4-bit, 4-place values to represent a binary number. This is for 2 reasons. One is for ease of reference, so that we can easily see the 4 values and understand what they are. And also these are the usage in hexadecimal, and that's why we have 3 columns here. So first column is 4-bit binary number, which represent 000 all the way to 111 at the bottom, and then we have the representation of decimal number, which is 0 up to 15. In hexadecimal, we have the same flow, except from 9th position onwards, it changes to alphabetical characters, which is A, B, C, D, E, and F, representing 10 to 15. So this is just to make it easy for hexadecimal. So for example, if I tell you 1111 in binary is actually represented by F in hexadecimal. If I tell you 1010 is actually A in hexadecimal. So that's how these hexadecimals play a role in usage in our computers. Now, as I said, we put it in 4s. However, one important thing you need to understand that 8 bits is equals to 1 byte, and we've heard about bytes and bits. So 8 bit is equals to 1 byte. If we fill in all these bytes with 11 11 11 11, what we end up having is the powers of 2 from 0 up to 7, which gives us 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. The total is 255. And 255, if we include 0, which that means from 0 to 255, we get 256 possible values in 1 byte. Okay, now to our topic of the day. Where do 16 million colors come from? Now this is where we go back to the basics again, where we understand about red, green, and blue being our basic color. And as I said, they actually represent a byte each, and a byte is 8 bits. Multiplied by 3, we get a 24-bit color model. Okay, so that means we have 1 byte of red, 1 byte of green, 1 byte of blue. That is 256 possible colors from 0 to 55, 256 of green and 256 of blue. Multiply all this, which is 256 to the power of 3, we actually get 16,777,216 possible colors. So a red goes to 25500, which is absence of green and blue. Green goes 02550, and then we have 00255. For your comments and understanding, let me know what you get with 000 and also 255, 255, and 255. And ladies and gentlemen, that's why we have 16 million plus possible colors, because of the RGB and the binary calculations that we've just done. Thank you, and hope you liked the video, and see you in my next video.